Next, I will show you how to apply the two means t pooled procedure to test a statistical claim about two population means when population standard deviations are unknown. Consider the following example. A group of activists want to verify the claim that in a certain Fortune 500 company, the average salary of female employees is different from the average salary of male employees. Two samples of male and female workers were obtained independently and analyzed. The sample of 19 women had the average salary $64,491 and the standard deviation $13,211. The sample of 24 men had the average salary $67,541 and the standard deviation $19,274. Test the claim at 10% significance level. First, let's note that the sample means are $64,491 and $67,541. The sample standard deviations are $13,211 and $19,274, and the sample sizes are 19 and 24 for women and men respectively. Now, let's identify the statistical claim that needs to be tested. The claim is that women's average salary is different from men's, so we can symbolically express the claim as mu1 is different from mu2, or equivalently as mu1 minus mu2 is not equal to 0. Since the claim is about the population means and the population standard deviations are unknown, we will use the two means t procedure. But how do we choose whether it is pooled or non-pooled? We use t-pooled procedure when the standard deviations can be assumed equal. Otherwise, we use t-non-pooled procedure. To test whether the standard deviations are the same, we set up a two variances f-test with alpha equal 10%. For convenience, we choose the same alpha as in the problem, but in general it doesn't have to match and depends on the context. The null hypothesis is that the two variances are the same. The alternative hypothesis is that the two variances are different. Next, we compute the test statistic using the formula, and we find it to be 0.47. We use technology to find the p-value and then compare it with the given significance level alpha. Since p-value is greater than alpha, we do not reject the null hypothesis. The conclusion is that we don't have sufficient evidence to reject the null hypothesis, and therefore we will continue assuming that the variances are the same and proceed with the t-pooled procedure. Before we begin the two-mean t-pooled procedure, let's check if all necessary assumptions are satisfied. The samples must be assumed simple, random, and independent. If not, then the results of the test are invalid. The central limit theorem must be applicable. In other words, the populations are normal or the samples are greater than 30. In our case, the samples are not greater than 30, therefore we must assume that the populations are normal. Also, the population standard deviations are unknown but assumed equal. To use the t-pooled procedure, we must compute the pooled standard deviation using the formula. The pooled standard deviation is equal to the following expression, and when we plug in all the data, we'll get the following answer. Also, the degrees of freedom of the involved t-distribution must be computed using the formula. The degrees of freedom are equal to 41. We will use the following template to perform the hypothesis testing. In step 1, we will set up the hypothesis. In step 2, we will identify the significance level. In step 3, we will find the test statistic using the formula. In step 4, we will perform either the critical value approach or p-value approach to test the claim. In step 5, we will draw the conclusion, and finally, in step 6, we will interpret the results. Since our claim mu1 minus mu2 not equal to 0 is in the form of an inequality, we're going to set it up as an alternative hypothesis. Therefore, the null hypothesis, which is always in the form of an equation, must be mu1 minus mu2 equal to 0. So the test is two-tail. Step 1 is complete. The significance level can always be found in the statement of the problem. In our case, it is 10%. Step 2 is complete. The test statistic can be computed using the formula. In our case, the test statistic T0 is equal to negative 0.602. Step 3 is complete. Next, we will test the hypothesis using two different approaches, the critical value and the p-value. In the critical value approach, we construct the rejection region. In this approach, we need to know the significance level alpha and the type of the test. We draw the rejection region under the t-curve with 41 degrees of freedom according to the type of the test. So two-tailed test will have the rejection region in both tails. The region must have the area equal to the significance level 10%. The boundaries of the region are the critical values, negative t 0.05 and t 0.05, which are negative 1.683 and positive 1.683. So the entire region can be described as all the values to the left of negative 1.683 or to the right of 1.683. In p-value approach, we compute the p-value. In this approach, we need to know the test statistic and the type of the test. We find the p-value using the t-curve with 41 degrees of freedom, according to the type of the test. So in a two-tailed test, the p-value is double the area to the left or the right of the test statistic, in this case to the left. Symbolically, it can be expressed as 2 times the probability of t being less than negative 0.602, which is equal to 0.550. Next, we are going to decide whether to reject or not reject the null hypothesis. In the critical value approach, we must check whether the test statistic is in the rejection region or not. Our test statistic is negative 0.602, and it is between the critical values negative 1.683 and 1.683. Thus, it is not in the rejection region. In the p-value approach, we must check whether the p-value is less than the significance level or not. Our p-value is 0.550, and it is greater than alpha. Both tests suggest that we do not reject the null hypothesis in favor of the alternative. Next, we are going to interpret the results. Interpretation. Under 10% significance level, we do not have sufficient evidence to suggest that women's salaries are different from men's salaries. I just showed you how to apply the 2 means t pooled procedure to test a statistical claim about 2 population means when the population standard deviations are unknown but assumed equal.